Hello. So, in this lecture, we will learn about the surface, meaning when this surface force is acting, it is acting in the surface. We know about this force. The surface force acts within the surface. This acts perpendicular to periphery. And always tries to minimize the cross-section area. Cross-section area. So it acts within the surface. Now let's define what is surface. The thing is, when in normal life we see the surface, for us surface means whatever is open to the atmosphere. But that's not the case with physics. In case of physics, we define the surface that whenever there will be abrupt change in density, not continuous but abrupt change in density, that cross-section area we will define as surface. So for an example, let's say there is a vessel, and inside the vessel there are multiple layers of different fluid. So I'm making 3 layers. So the thing is, let's say the density here is rho, density here is twice rho, and density here is thrice rho. If in this case, if somebody will ask you how many surfaces are there, we'll say there is only one surface which is open to atmosphere, but that's not the case. The thing is, when you go from the bottom to up, there is a same frequency, same density, so there is no surface. But the thing is, the moment you reach at this point, you cross this point, density abruptly changes from rho to twice rho. So for us, this is surface 1. Then it remain constant. You cross it, you get second surface. It remain constant. You cross it, you get third surface. So from the bottom to the up, you crosses through 3 surfaces there. And at each and every surface, within each and every surface, there will be surface force. This force will be acting. So the thing is, before applying this force, we need to know how to identify the surface. Okay? Because in each and every surface, this force will be acting. Now, in the previous lecture, we have defined the surface tension using this structure. So we were talking about this force. Now what we do, let's take this view. If I take this view, I will see a straight line, and that straight line represents this moving rail. So this is the straight line. This straight line represents this rail from this side, if you see. And then you will see a width. And this width represents the surface. This width represents the soap solution, or it can be water also. I'm taking the soap solution because that's what we generally do, soap solution. So see, what you will see here, this side there is this air, on the bottom there is air, upper side is also air. So if you move from this side, you cross this surface and this. So almost zero density to non-zero density, then non-zero to zero. So when you go through this, you get through 2 surfaces. There is S1 and there is S2. And in each and every surface, there will be force which will be acting. And that force is nothing but this Fs. So in this case, I'm only showing you one surface force, but there will be 2 types. One at the downside and one onto the upper side. Here also there will be surface force, and here also there will be surface force. So what happened when we study this topic through NCERT and through numerous books? People tend to combine them. They tend to make the formulas for single surface separate formulas, double surface separate formulas. And that's what makes us confusing. And that's what we always gets confused because of these, whether what formula to use for single surface and what formula to use for double surface. The thing is, I always teach my students, whenever you are making any formula, make that formula only for single surface. Calculate the force for single surface, and then after you can make the FBD. If you find that there are 2 surfaces, you apply the forces onto both the surfaces because you have already calculated the forces on each and every surface. And then corresponding to that, you can measure the acceleration or whatever you want to measure. So from now onwards, whatever formula I will make, in that formula, I will only take the force which is acting onto the single surface. I'll make each and every formula for single surface alone. So previously, if you remember, the formula was Fs upon L, and that was equals to surface tension. Okay. So this formula I'm making only for single surface. This is for single surface. The T will not change whether you take the one surface or two surface or three surface till it's of the same material. It will not change. What will change is the L and Fs. The thing is, what they do, what the people do, for single surface they tend to take the L, and for multiple surfaces they tend to take 2 and 3 and 4 like that. And similarly, whatever value you are changing it here, the same value changes at the Fs also. But we will not do that. For us, the length of periphery, this is the length of the periphery at one surface, and this is the force at periphery only in the one surface. That's how we will always calculate. For this is the force which is coming in single surface. Single surface. And this length also we will measure across the single surface. For single surface. We will not go for 2 or 3. What we will do, we'll calculate the force in single surface, then we'll calculate the force in other surface, and we'll take the vector addition of those two forces. Okay? That's how we will proceed. Each and every formula we will be making for the single surface, not for 2, not for 3. Formulas will be made only for single surface, and then after we can do the vector addition or scalar addition depending upon whether you are talking about the force or you are talking about the energy, if you want to add them. Okay? Okay. Thank you.